Okay, Year 12. We're looking at precipitation reactions for anions in this video. So here's the table for the textbook, talking about carbonate, hydroxide, chloride, bromide, iodide, sulfate, phosphate, and acetate, or ethanoate, as we prefer to call it. Okay, so each has their individual tests there, but it sometimes helps to think about them in a flowchart. And there's a flowchart in the textbook as well, which we'll break down and I'll put in a different form with some images. So first up, we're going to test the bases, okay? You'll notice one of the early thing is testing with red litmus. Okay, look what I did here. I put in the wrong way around. So first we want to test with red litmus paper, and if it turns blue, we know it's a base. Not like what I've got in this image here, okay? So once we know it turns blue, we know we've got one of the bases, and we're talking about carbonate, ethanoate, or acetate, and hydroxide. Okay. So first up, we're going to add nitric acid, HNO3. Okay. We're either going to get bubbles or no bubbles. Bubbles would suggest, because we're adding an acid, that we've got a carbonate. CO2 being given off, okay? So there we've reached an endpoint, we've identified our carbonate. But if we don't have any bubbles, we don't know whether we've got the hydroxide or the ethanoate, okay? So here what we're going to do, and it's a test we learned earlier, we're going to add some copper nitrate. Well, we're going to deliver some copper 2+, okay? Because copper hydroxide is that blue distinctive precipitate there, copper hydroxide, okay? And we added copper to the ethanoate ion and we get no precipitate, we just get a lighter blue solution, okay? So not that dark blue. Another thing that can hint that you've got an ethanoate solution is that it smells awfully similar to vinegar. Not quite exactly the same, but very similar too. So you can use your nose to test out there too, and I added it in yellow. So that's one branch for our anions, once we've established that we've got the bases here. Okay, let's go back up to this other one where we haven't got a base there. Okay, so it stays red. Okay, our red litmus stays red. What we do in there is we're going to add some silver. Okay, and we deliver it by delivering some silver nitrate, okay? And we get a precipitate. And this helps us distinguish our halides, okay? Because we get distinguishing precipitates for iodide, chloride, and bromide, okay? Iodide is a yellow precipitate, silver iodide. Chloride is a creamy precipitate, and silver bromide is a white precipitate, okay? Fluoride doesn't precipitate, okay? So down here I've got the equations for them, yellow, cream, and white. However, if you don't have them next to each other, sometimes the difference between silver iodide, the white, and the yellow, the cream and the yellow can be a bit iffy. You're like, oh, I don't know which one. So that can be a bit tough, okay? To ensure you've identified the correct precipitate, you can add some ammonia to it, okay? So dilute ammonia will react with the white silver chloride to form this complex and turn clear again, okay? So dilute ammonia will make the chloride clear again, okay? The bromide, though, won't change, okay? A concentrated ammonia solution will then react with the bromide to turn it clear, okay? The iodide, silver iodide, cannot be dissolved in either dilute or concentrated ammonia solutions. So you can pull out the ammonia just to make sure with those colors, okay? So we kind of got down here. Oh, we've done the whole lot, okay? So add dilute ammonia, and that one, add concentrated ammonia, that one turns clear. The iodide never changes. All right, we've done that branch, okay? The other one here, once we add the silver in, we had the option of we're adding silver and it has no precipitate. Okay, so this is for sulfates and phosphates are the ones left over. Okay, so what you do then is you get a fresh sample of your solution, so that hasn't had the silver and all that crap added, and you're going to add dilute nitric acid and barium nitrate. So we're going to deliver some barium 2+ to it, okay? Because we know that barium sulfate is a white precipitate. It comes up all the time. So adding barium 2+ to it through barium nitrate, and we get a precipitate, we go, that must have been the sulfate. If it didn't have a precipitate, what we do is, just to make sure, we can assume it's phosphate, but just to make sure, we get a new sample that hasn't got the barium added and doesn't have the silver added and all that other stuff. We can add some ammonia and some barium nitrate, and what we do then is we get a white precipitate. Okay? Alright, so here's another table, same kind of idea. And here's my table that I'm going to print up with for you. So it's kind of like the one in the textbook, but I've added the images into it as well. So, first up we test red litmus, okay? And if it goes blue, we do the nitric acid, and then the copper nitrate, we need some copper. If it stays red, we add some silver to precipitate out the halides. If it doesn't precipitate, we add some barium to see if it precipitates for the sulfate. If not, it's the phosphate. Alright, here's some questions from past papers. We've got a flowchart that shows the steps to identify a sample of a substance. Flame test is our test 1. Then we're dissolving the sample in water, then adding hydrochloric acid, and then adding barium. Okay? If the substance is sodium sulfate, okay, what should be observed in test 1, 2, and 3? So test 1 is the flame test. So we should see a flame test for sodium. If we go back up, we should see an orange colour. Let's look at the sodium flame. Oh, hold on, I went past it. Look. Oh, sodium's not on there. Oh, because it's not on the list. But sodium is an orange flame. Oh, that's a terrible question. We didn't learn that one. It's not on the list for flame test colours, but sodium is your orange colour, like your sodium lights, like the street lights. Alright, where was I? So it's going to be an orange, a bright orange flame, not a blue-green flame. Okay? So we can cross out C and D, because we're not getting a blue-green flame. Test 2 is after we've dissolved it in water, and we're going to add some hydrochloric acid. Okay? Some acid to our sulfate is not gonna form an acid-base reaction and form bubbles. So this one's out. No bubbles are going to be formed. Okay, let's just check the last one. If we add barium to our sodium sulfate solution, we're going to get barium with sulfate, and barium sulfate is insoluble, so we are going to produce a white precipitate. So there, the answer is A. Okay. A solution containing 3 cations, barium, copper, and lead, and the flowchart indicates a plan used to confirm the identify. So we've got our solution. We're going to add some acid to it and filter it. Okay, we're going to get a precipitate, and we're going to get some staying in solution. So what will precipitate first? Knowing our solubility rules, copper chloride is soluble, barium chloride is soluble, but lead chloride is not soluble. So that's our lead chloride there. So going down here, we've still got barium 2+ and copper 2+. Okay, we're going to add some sulfate to it. We know that barium sulfate is insoluble, so that's going to be our precipitate, barium sulfate. And so we've still got our copper 2+ solution left here as filtrate 2. So precipitate 2, we've determined that, that's barium sulfate. Write a balanced net equation for the precipitate 1. Okay, we've got 2+ and plus 2 chlorides going to PbCl2 solid. Okay, suggested test and the expected result that would confirm the identity of the metal cation remaining in filtrate 2. So suggested test to test for copper. Okay, so copper will precipitate with hydroxide to form a deep blue. Copper 2 plus aqueous plus 2 hydroxides aqueous will form copper hydroxide solid, which is a blue precipitate. So that's our test. Okay, so if we take this filtrate and we add hydroxide to it, we get a blue precipitate. Hey, that was your copper. Okay, you got a worksheet, and we'll leave it there.